Well, this is Mr. Precella. We're starting back on this problem number 7. For some reason, the video froze, so we had to stop it and start all over. Notice we're trying to graph a parabola. We went through, and we're creating ordered pairs. So, continuing on with what we were doing, we had plugged in -1 for x and got the y value of -2. And now we're going to plug in 0 for x. That's going to give us y equals -2 times 0 squared. What's that going to give us? I couldn't hear you. 0, I agree. 0 squared is 0 times -2 is 0. And finally, we're plugging in +1 for x. Plugging in a +1 for x. We get y equals -2 times 1 squared. Well, isn't that going to give us the same thing that we got when we plugged in -1? Because -1 and +1 squared are still just 1 times -2 gives me a y value of -2. So we have 3 ordered pairs to plot. We have 3 ordered pairs we're going to plot. And notice for this problem, we don't have to type in the ordered pairs. We're just graphing the equation. So the first ordered pair, well, we click the 3-point quadratic tool. We know this is quadratic. We have 3 points. Click. And then start plotting the points. -1, -2. There. And then what's the next point? 0, 0. So it's passing through the origin. There. And the last one? 1, -2. Notice how tight that is. Be looking there. So that 1, -2. Look in that yellow box to make sure that you have the point where you want it. Save it. Check answer. Notice something. Looking at the equation, what's the leading coefficient? -2, and specifically it's negative. When the number in front of x squared, when the coefficient of x squared is negative, you expect your u to open down. Whereas, when the coefficient of x squared is positive, if it's a +1, you expect the graph to open upward. The point where the graph changes directions is called the vertex. We're going to get a very nice little formula that we can use to determine the location of the vertex. But that'll be in a couple of weeks when we look at graphs of quadratics in more detail. Any questions there? Okay. Our third type of equation we're going to be graphing is conics. I mean cubics, not conics. Cubics. There. Is it my imagination or does the display look darker? The light's still on here, but it just looks like it's getting darker up there. Well, who knows? Okay, so cubics. A cubic has an x cubed term. That's one thing I like about this. I can look back and see, what did I do? What did I write? You know, yeah. Here I was on Thursday. Must contain an x cube. Okay, so I say cubic has to have an x cubed term. Now, the graph of a cubic doesn't have a official name. I suppose if I wanted to give it a name, I'd call it a squiggly. So, looking at number 5. No, not number 5. Number, where is it? No, not that one. Where is it? I don't even have it listed here. Ah, here it is. Let me make a note. I should do 6 there. Okay, number 6. And notice the equation, that cube stands out there. That tells you that you're going to be graphing a cubic, which means you have to use the cubic tool. For the equation y equals x cubed minus 3, create a table with ordered pairs that are solutions, and then graph the equation. Well, I'm glad they're giving you the x values to plug in. Once again, you wouldn't want to use something like a 10. 10 cubed is 1,000. Minus 3, I'm sure that you can't go 997 units up on the y-axis. Notice they're having you use the x values you're plugging in are real close to 0, because as you cube those x values, they start exploding. 5 cubed is 125, so by the time you get out just 5 units to the right, you're way up over 100 units from the on the y-axis. Notice the numbers they're giving you are very close to 0. Let me write the problem down. This is number 6. Y equals x cubed minus 3. And we're making a table of values. Plugging in 4 numbers. -1, 0, 1, and 2. Let me switch back to my paper. So we'll start by plugging in -1 for x. We're plugging in -1 for x. We get y equals -1 cubed minus 3. -1 cubed, that's -1 times -1 times -1, which gives me, not 1, -1. -1 times -1 is a +1, times the other -1 becomes a -1 minus 3, which equals -4. I like odd exponents. People, if they had to choose, they like squares better than cubes. Well, I like cubes because they don't change signs. If the number you're plugging in starts negative, it stays negative. Oh, what about 0? I think we can do that in our head. Plugging in 0 for x, what are we going to get for y? Okay, 0 cubed is 0 minus 3, I agree, is -3. Now we're going to plug in a +1. Okay, plugging in a +1, we get y equals 1 cubed minus 3. 1 cubed is 1 minus 3 is -2. Notice when you plugged in -1, you had a -1 minus 3. When you plugged in a +1, you had a +1 minus 3. Only one more x value to plug in. They want us to plug in the x value of 2 to give us y equals 2 cubed minus 3. Be careful, what's 2 cubed? 8. It's not 6. It's 2 times 2 is 4, times another 2 gives us 8 minus 3, which equals 5. Any questions there on how we filled in that table? So let me see, we're going to be punching in -4, -3, -2, and 5. So we come back over here. We're going to punch in -4, -3, -2, and 5. Is that what I wanted to enter there? So check answer. Okay. Now we're going to draw the graph. We know this thing is a cubic, so we have to find the cubic tool. Oh, I know it's not this. That's a line tool. I don't know why it's not. There it is. We've already seen that this is going to be the absolute value tool that we're going to use in a moment, and this is a quadratic. Well, we're not graphing a circle. We're going to see this circle tool, and it is such a nice graphing tool. But that'll be another assignment, okay? But I think it's right here. What does that say? When you hover over it, it says 4-point cubic tool. Isn't that what we have? We have 4 points, and it's a cubic. So I'm going to click that tool. Now they want us to plot the first point. The order doesn't matter. I could plot 2, 5 first if I wanted to, but I think I'll plot them in the order in which we found them. The first point, oh, by the way, notice they're changing the width versus the height. The x values, notice those numbers have a wider gap between them. The y values, you see they've changed the scale, so be careful. We needed a -1, -4, and that's why when it's important, just look up there in that yellow box. Is that -1, -4? Yes. And then 0. Is it -3? 0, -3, is that it? And then what's the next one? 1, -2, okay. Is that 1, -2? Do y'all see where it says it in the yellow box? Yes. And notice at this point it really looks like a line, doesn't it? But by the time we get to 2, when x is 2, the y value is what? 5? Oh, no, that's not it. There. Is that it? 2, 5? Yes, it is. Notice the first 3 points, it sure looked like a line. But because of that cubing, when you take a number, especially if it's a number way out on the right or left of the x-axis, when you cube it, you're going to get a really big number. So, save, check answer. Any questions there? And let's see, number 5. Number 5. When I look at number 5, one thing just stands out. And it's that stuff that stands out that's going to give this equation its name. What do you think we would call this type of equation? An absolute value equation. Yes. So, for an absolute value equation, and this is important what I'm about to say, because for the absolute value graphing tool, the order in which you find those points, the order in which you plot them is important. You'll be getting 3 points, I believe, but the order in which you're plotting the points will make a difference. The graph of an absolute value expression. Let me write this down. I'm not going to bother writing down that problem yet. Absolute value graph. Its graph is going to be a V-shaped figure, and a V-shape to me has a sharp point. That's why a parabola, a quadratic, has that smooth. Oh, it's supposed to be symmetric, okay? The right side should look like the mirror image of the left side. It can be opening upward, or it can be opening downward. the graphing tool for absolute values, they want you to plot the vertex first. The vertex is the point where the graph changes directions, there or there. There's the vertex. To determine the location of the vertex of an absolute value expression, you have to ask yourself, when is the inside stuff equal to 0? The vertex occurs when the stuff inside the absolute value bars is equal to 0. I should say when the expression inside the absolute value bars, but stuff is fewer letters. So the vertex occurs when the stuff inside the absolute value bars is equal to 0. So let's switch back to that number 5. Let me write the problem down. Y equals the absolute value of x minus 4. And they're going to give us a table of values that they want us to complete. The instructions say you're going to be getting at least 3 ordered pairs. Well, it's going to be exactly 3 ordered pairs. And the first number they want us to plug in is a -5. Okay. I like it better when they just give us all of the x values all at once, like in the with the cubics. But here they're only giving us one x value at a time. Let's start off with -5. Plugging in -5 for x, we get y equals the absolute value of -5 minus 4. -5 minus 4 is, so we have the absolute value of -9, which is, what's the absolute value of -9? Okay. So there's the first order pair we found. We plugged in -5 for x, and that gave us a y value of 9. So we have to come back over here and type in a 9. Oh, the next one, 4. They want us to plug in 4 for x. That'll give us y equals, we're plugging in 4 for x, that's going to give us y equals the absolute value of 4 minus 4, I agree, is 0. And the absolute value of 0 is so our second order pair is 4, 0. And that will be the vertex. Remember, the vertex occurs when the stuff inside the absolute value bars is equal to 0. What number would make that stuff there equal 0? 4. I'm going to even write out here beside it, vertex. So when they're giving you a table for the absolute value graph, one of the numbers they tell you to plug in must correspond to the vertex, because the graphing tool for absolute values, first thing they're going to do is say plot the vertex. You're not going to start by plotting -5, 9. You're going to start by plotting 4, 0. But there's another point they want us to find. Let's see. Oh, I better type in 0 there. Oh, no. I better type in 0 there. Okay. And finally, they want us to to plug in 15 for x. We're plugging in 15. What's that going to give us for y? I think we can do that in our head. 15 minus 4 is 11, and the absolute value of 11, I agree, is 11. So we come over here and type in 11. Any questions on how we completed the table? Any questions on how we knew that the vertex was at 4, 0? When is that step inside there equal to 0? That's the location of the vertex. So click here. We have to click our absolute value V, or absolute value tool, and notice what it says when you click it. It doesn't say just plot a point. Click the graph to plot the vertex. They want you to plot the vertex. That's why you have to know that the vertex was at 4, 0. Okay? So we come over here, click 4, 0. Is that the point I wanted? Yes? And then notice, it says click the graph to plot another point. We only need one other point. They had us find 3 points, but we didn't need 3 points. All we need is the vertex and one other point. Notice how it's symmetric. So once you plot one point, the other side's going to get done automatically. So what do y'all want to use? Which other point do y'all want to use? Do you want to use -5, 9 or 15, 11? Doesn't make a difference to me. 15, 11, so I'm looking right out here at that yellow box rather than trying to count those things. 15, is that it? Yes, it is. And notice how it gets the other side done automatically. What about -5, 9? Can y'all count that? There's -5, and right out there, -5, 9 is on the graph also. So save it and check. Any questions there? Okay. And that was number 5. Let's look at number 8. And there's only 10 problems in new material here. Starting at 11, it's older material designed just to not let you forget what you've already seen. So, number 8. Hey, it's another absolute value graph, isn't it? But what are they not giving us? They're not telling us the x values to plug in. We have to choose our own x values. So let me write the problem down. This is number 8. Y equals the absolute value of x minus 7. Okay. The first thing I would do is determine where the vertex occurs, because that's going to be the first point they want you to plot with these absolute values. The vertex occurs when that inside stuff is equal to 0. So, when x is 7, you've got to plug in 7 for x. You're going to have to plug in 7 for x, and that will be our vertex. Well, the y-coordinate's pretty easy then. I think we already know it. What will the y-coordinate be? 0, okay. Now we need another x value. We need another x value to plug in. What do y'all want to use? I always just use something close to the location of the vertex. What do you think? 8, 9, 5? Did you say 5? Okay. So we have, when x is 5, we get y equals the absolute value of 5 minus 7. 5 minus 7 is 5 minus 7 is negative 2. And don't write down negative 2 for the y value. What do you have to do? Okay, the absolute value of negative 2 is a positive 2. We could have used 8. If we had used 8, what would we have gotten for y? 1 out of the way. You still get the correct graph. So we click the graph to enlarge it. We have the absolute value tool. And you plot the vertex first. That was 7, 0. Was that it? Yes. Oh, and now they want the other one. What? Wait a minute. Right, let me see. Did I move that? No, that's 7, 0, okay. The second one, 5. This mouse is very touchy. 5, 2, is that what I wanted? Yes. Now, I would have used 8 and gotten 8, 1, and notice that point is on the graph. So, the secondary point, whatever number you use, it's going to be there on that graph. Now, you can't use something like an 11 for x, because notice the grid ends at 10. So be careful when you're choosing. Save it to transfer it over and check answer. Any questions there? So we have, let's see, we've graphed lines, quadratics, cubics, and absolute value expressions using using graphing tools. There's one other thing we're going to graph. Square root, graphs of square roots. I guess I could say graphs of square root expressions, but I think I'll just say graphs of square roots. It's less writing. There's no graphing tool embedded in this algebra book for square root graphs, which means it'll just be multiple choice problems, okay? The approach that I take for these is similar to what I do with absolute values. I ask myself, when is the inside stuff equal to 0? Because remember, you don't want imaginary y values. A number is imaginary because it can't be labeled on a number line. That's why we have imaginary numbers. Those numbers can't be labeled on a real number line. So whatever you plug in, you sure don't want to plug in a number that will give you a square root of a negative number. For example, y equals the square root of x minus 1. I always like to plug in 0. 0 is usually pretty easy. But in this case, could I use 0 for x? You're going to be choosing your own numbers to graph these things. Could I use 0? No, I could not use 0, because if you try to use 0, you're going to get y equals the square root of 0 minus 1. That's the square root of -1, and that is imaginary. No. So to make sure you don't get imaginary numbers, what's the smallest thing you can have under a square root and it not be imaginary? No. Well, for this situation, you're right, okay? But for just a generic square root, here's a generic square root. What's the smallest number I can put under there and it won't be imaginary? Starts with a Z. 0. The square root of 0 is 0. You try to plug in any other number there smaller than 0, you're going to get an imaginary number. So my approach is I ask myself, when, it's the same question I ask myself with absolute values. When is the inside stuff equal to 0? I ask myself, when is the inside stuff equal to 0? So for this example here, when is x minus 1 equal to 0? When x is 1, so 1 is our starting point. We'll either be graphing to the left of 1 or to the right of 1. So I think I'll go ahead and graph this one, even though it's not the, we'll do the homework problem in a moment, okay? But this is a good example. We're going to start by using 1 for x. I'm going to plug in 1. What's that going to give me for y? Okay, 1 minus 1 is 0. The square root of 0 is 0. I agree. Now, on one side of 1 on the x-axis, you're going to get imaginary numbers, and on the other side, you're going to get real numbers. So with that in mind, what side should we go? We've already said if we tried to plug in 0, what's going to happen? It's imaginary. So we don't want to go to the left of 1. So why don't we plug in numbers like 2 and 3 and maybe 5. Plugging in 2, we get a nice y value. Plugging in 2, what are we going to get? 2 minus 1 is the square root of 1. We're plugging in 2. We get the square root of 2 minus 1, which is the square root of 1, which is 1. What are we going to get when we plug in 3? What will we get when we plug in 3? 3 minus 1 is 2. We get the square root of 2. That's about a 1.4, okay? But it can't be reduced other than just, you can use a calculator and get a decimal approximation. But I think I'll just leave it like that. I'm not even going to label this point. I'm going to use the points that have give us perfect squares. What are we going to get when we plug in 5? Plugging in 5. Oh, wait a minute, I think it's the square root of 4, isn't it? I skipped over 4 and went straight to 5 to get a perfect square. The square root of 4 is? So we have, I think we can get a good picture with these 3 ordered pairs. 1, 0, 2, 1, and 5, 2. We're going to have to draw our XY grid. Since I made this problem up myself, there's not a grid to graph it on, so we'll have to so we draw our XY grid. We have the ordered pair 1, 0, so write 1 up 0. we have the ordered pair 2, 1, right 2, up 1. And what's the last ordered pair I'm going to label? I'm not going to do the 3 square root of 2. 5, 2, right 5, 1, 2, 3, 4, 5, up 2. 1, 0, that's where we start the graph, and it goes slowly upward. It's increasing very slowly. So if we moved out, let's say 11 units, if we had an x value of 11, no, not 11, if we had an x value of 101, 101 minus 1 is 100, the square root of 100 is 10. So if we were way out here at 101, way past the graph, we're only going to be up about that much right there. So the graph is increasing, but it increases very slowly. So, to graph a square root expression, ask yourself, where does it equal 0? Decide which side gives you imaginary numbers, because you don't want to use those numbers. And then choose a few other x values, preferably something that gives you perfect squares to get the graph drawn. Maybe we better look at, which number is this? Number 4, I think. Okay, so we're looking at number 4. Oh my goodness, I can't believe this. It's the one that we just graphed. Y equals, isn't that? Hey, let's look and see, okay. Y equals the square root of x minus 1. Let's choose the correct answer. Notice if I want to make the graphs pop out, I can either blow it up or have the little graphs pop out. I think I'll do it like that. Is that the one I wanted? No. What about B? No. What about C? Yes, I think that's the one I want. If you look at D, clearly not. So the only one that's even remotely close is response C. Oh, let's see, I think I'm going to say similar question so we can do. Well, okay. It's very similar, but that's okay. Y equals the square root of x minus 2. We want to draw the graph. So where's the starting point going to be? What x value will be the starting point of the graph? 2. And you're asking yourself, here's what you're thinking. You're thinking to yourself, when does x minus 2 equal 0? That's when x is 2. So you have a little table of values. When x is 2, y is 0, okay. Now, suppose we tried to go back to 1. Suppose we tried to use 1 for x. If we plug in a 1 for x, what's about to happen? You get the square root of negative 1, and we know that that's the I. We can't do those. So we can't go to the left of 1 on our grid. How about let's plug in 3. Plugging in 3 for x, what are we going to get? 3 minus 2 is 1. The square root of 1 is 1. I'm not going to use 4 because 4 minus 2 isn't a perfect square. If we use 6, that's a good number to use. If you use 6, plugging in a 6 for x, 6 minus 2, that's the square root of 4, which equals 2. These 3 ordered pairs right there are enough to give us a very good picture. So I'll draw my XY grid. Okay. Oh, look at those wavy slanted. These things are really vertical and horizontal, but when I'm doing it, freehanding, you'll notice they're a little wavy, and that's good enough. We're not building bridges or anything. Now, if you're going to be building bridges, you need to be real exact. As all of us in Corpus Christi have learned, that math does matter when it comes to building bridges. We were talking about the new Harbor Bridge and the delays before class. If you're building bridges, you need to be real exact with your mathematics. But we're not, so we'll just say that's good enough, even though my y-axis is so wavy. So we have 2, 0. We have the point 3, 1. So 3, 1. And 6, oh wow, 6, 2. Oh, I gotta go way over here. There's 6 up 2. Do y'all see the shape? It starts here and it goes up like that. Any questions there? Okay. We got A, B, C, or D. I think it's another C, isn't it? I think I'll pop it out so it's bigger. There it is. Looks like they're incrementing in units of 2. There's 2, 0. There's 6, 2 right there. I agree. It's option C. Any questions there? We have a couple. We're going to end this assignment with a couple of important formulas. The distance and midpoint formulas. Distance. Let me write this down. Get over here to number 9. Okay, and there. The distance and midpoint formulas. Let's suppose that we have 2 arbitrary ordered pairs. I'm going to call them x1, y1, or x sub 1, y sub 1, and x sub 2, y sub 2. Here I'm drawing a line segment. Once again, it's sort of a wavy line segment. For what we're doing here, we're not building bridges. We can say that's good enough for this illustration. So I'm going to say one of the endpoints is x1, comma, y1. Technically, it's x subscript 1, y subscript 1, or we can read it as x sub 1, y sub 1. Out of laziness, I just say x1, y1. And the second order pair, I'm going to label x2, y2. The distance from one point to the next. Imagine taking a measuring tape, putting the end here and stretching it to the other end. Or you can put it here and stretch it back like that. The distance is the length of that line segment. That distance is the length of the line segment, and I'm going to denote that with just a lowercase letter d. The midpoint is exactly what it sounds like. It's the point that's midway along that line segment there. It would divide the line segment in half by length. Where would that midpoint be? It's right in the middle. Does it look like right out here? So this red point is the midpoint. The length of the segment is the distance. To find the length of that segment, we have something called the distance formula. D equals the square root of, it's a big square root. You subtract the x coordinates in any order. I always go x2 minus x1. So it's x2 minus x1 quantity squared plus, then we subtract the y coordinates in any order, y2 minus y1 quantity squared. Subtract the x coordinate squared plus subtract the y coordinate squared, and then take the square root of that sum. The midpoint, by the way, this formula is derived pretty easily using the Pythagorean theorem. If you remember the Pythagorean theorem, a squared plus b squared equals c squared. The midpoint is the ordered pair whose x values are midway between the given x values, and the y value of the midpoint is the number that's midway between the given y values. You're just averaging the midpoint to find the point that's midway along that line segment. You average the x coordinates. To average two numbers, you add them up and divide by 2. So x1 plus x2 divided by 2, comma. To find the y coordinate, you average the y coordinates that you're given. y1 plus y2 divided by 2. And number 9, they're giving us two ordered pairs, and they're naming their ordered pairs. One point is P, it's located at -6, 16. The other point is Q. Q is located at the ordered pair 121. Find the distance d of PQ. They're using a function notation that I don't care for because we haven't defined functions yet, so I'm just going to call that distance d. And then find the coordinates of the midpoint. Let me write down these ordered pairs. This is number 9. We have the ordered pair, -6, 16, and 1, 21. We want to find the distance from those two, from one point to the other, and we want to find the midpoint of the segment connecting them. What I do is I label these points. The first ordered pair I write down, I label x1, y1. The second ordered pair I write down, I think of as x2, y2. And the distance formula. We got to subtract the x coordinates and then subtract the y coordinates. x2 minus x1. So we have a 1 minus, what's going here? -6, I agree. And then y2 minus y1. So we have a 21 minus 16. So continuing. Be careful, what's this 1 minus -6? That's a 1 plus 6, which gives me a, so we have a 7 squared plus 21 minus 16. What's that? Oh, that's 5. So 5 squared. Let's see. 7 times 7 is 49. Plus 25, I agree. And is that a 74? 49 plus 25, I'm getting the square root of 74. Is 74 a perfect square? Now, it's a while since we looked at our little list of perfect squares from the first day of the semester, but is 74 a perfect square? No. And you can try using any of these other numbers to divide evenly. It can't be. You can't reduce the square root of 74. None of these other perfect squares divide in evenly. Our final answer is just going to be left as the square root of 74. And now they want the midpoint. It's an ordered pair. Remember, you average the x-coordinates and you average the y-coordinates. You're trying to ask yourself, on the x-axis, what number is midway between -6 and +1? So you add the x-coordinates, -6 plus +1. What am I going to put here for the y's? Here, plus -6 plus 1, that's -5. So we have -5 over 2. Leave it as an improper fraction, but what would that be as a mixed number? -2.5? Is -2.5 midway between -6 and +1 on the x-axis? Yeah, that sounds right to me. I would think -2.5 is right there in the middle. What number is midway between 16 and 21 on the y-axis? 16 plus 21 gives me a 37 halves. What is that, 18.5? Yeah, I guess 18.5 would be right in the middle between 16 and 21. That sounds like a sensible answer. Any questions there? And I come over here. And first thing they want is the distance. I click in the box and my little toolbar pops up. What am I going to click first? Square root of 74. Okay. You see, you used to be able to hit enter and it would just go on to the next one. It doesn't do that anymore. You got to click the OK. At least not on this computer that I'm using up here. Now we want to type the coordinates of the midpoint. Left parenthesis, what was it? -5 over 2. Get out of that denominator before you type your comma. And then the y-coordinate was 37 halves. Get out of that denominator before you close your parentheses. Is that the answer we got? So let's check. Any questions there? Number 10 is just like that one. So, y'all want to do it, or do you think you've had enough? Let's do it. That way, I would have done all 10 of the new material problems. Okay, let me write it down. So we have the point 17.8 and the point 22.11. I'll label the first point I write down, I'm labeling x1, y1. The second, I'll write x2, y2. Although it doesn't matter, you could have labeled this point x1, y1, and this one x2, y2. The distance from point A to point B is the same as the distance from point B to point A, or P and Q, whatever the name of these things. Our distance formula, I'll go ahead and write it down. x2 minus, just so I have something to point at in a moment. I'm rewriting my distance formula. Okay. I'll let y'all call out these numbers here. 22 minus here. Okay. Here. 11 minus. And 22 minus 17 is 5, so we have 5 squared. 11 minus 8 is 3, so we have 3 squared. So that's 25 plus 9, which gives me a, and the square root of 34, can that be reduced? No, it can't be reduced. And now the midpoint. The midpoint, you're just averaging. Average the x coordinates, average the y coordinates. And to average two numbers, you add them up and divide by 2. So we're averaging here 17 plus here 8 plus 11, good. So we have parentheses, 17 plus 22 is 39 over 2. What are we going to have for the y coordinate of the midpoint? 19 over 2. So we go to go back to MyLab and we punch in the distance plus the square root of 34. The midpoint, left parentheses, 39 over 2. Get out of the denominator before you type your comma, and 19 over 2. Get out of the denominator. By the way, I'm hitting the right arrow. That's how I move out of those denominators. You can click with your mouse, but it just seems to me like it's quicker just to do a right arrow, especially when you have a touchy mouse like mine. So check answer. Any questions? And starting at number 11, it's old material. Oh, I remember that. I remember almost that exact same problem. So 11 through 15, it's just old material to try to make sure you don't forget the stuff. Looks like it was stuff from rational equations. So, any questions there? so uncomfortable to say this. I really dislike badgering students, but realize if you haven't set up your MyLab account, this is the 5th week of the semester. If you haven't set up your MyLab account, you haven't done any of the homework. Can you take tests if you haven't done any of the homework? The way the course is set up, every assignment has those prerequisites. You can't just decide, I'm going to start working on assignment number 9 today. You have to have done all of the first assignments. But the ones before that, there's a quiz coming up. There's a test coming up. If you haven't set up your MyLab assignment, are you able to take the quizzes and tests? No. If you haven't set up your account, at this point you have said, I'm going to fail the class. It's not too late, but you got your work cut out for you. Any questions?